Welcome. Now, lean back and take a deep breath. Slowly let go of all the fatigue you've carried through the day. Because tonight, together, we'll drift gently into the quiet and peaceful embrace of the universe. Far beyond the stars you can see, the universe quietly helps us look even deeper into its own past. Even a telescope as powerful as Hubble has its limits. Some galaxies are simply too distant, too faint, too ancient. Their light has traveled across billions of years, becoming weaker with every moment of its journey. At first, it seems impossible to see them. But nature has created something extraordinary. Gravity itself can become a telescope. Imagine a massive galaxy floating silently through space. It contains billions of stars, vast clouds of gas, invisible dark matter, and an enormous amount of mass. That mass gently bends the fabric of space around it. Nothing escapes this effect. Not planets, not stars, not even light. Although light always follows the shortest possible path, the path itself is no longer straight. Space has been curved, so the light slowly changes direction as it passes near the galaxy. From our point of view, the galaxy becomes a giant natural lens. Light from an even more distant galaxy is bent toward us, making something almost invisible suddenly appear. Sometimes the distant galaxy stretches into long glowing arcs. Sometimes it appears more than once, and on very rare occasions, everything aligns perfectly. The distant light forms a complete circle around the foreground galaxy. These breathtaking shapes are known as Einstein rings. They are among the rarest sights ever observed in the universe. Every one of them is a reminder that space itself is not empty. It has shape, it has structure, and gravity can gently reshape everything that travels through it. This natural lens does more than reveal hidden galaxies. It also magnifies them. Details that would normally remain forever beyond our reach become visible. Galaxies born shortly after the universe itself can suddenly be studied in remarkable detail. Without gravity, many of these ancient worlds would still be invisible to us today. Sometimes the effect becomes even more extraordinary. A single distant quasar may appear 2, 4, or even 5 separate times across the sky. It looks as though several identical objects exist. But in reality, it is the same beam of light, following different curved paths through space before finally reaching Earth. By carefully studying these distorted images, astronomers can measure the distribution of hidden matter, test Einstein's theory of gravity, and even improve our understanding of how quickly the universe is expanding. What first appears to be a beautiful cosmic illusion becomes one of the most powerful scientific tools ever discovered. As you continue drifting through the silent darkness, you realize something remarkable. The universe is not only waiting to be explored. Sometimes, it quietly helps us find the way. Far away, hidden inside a cloud of gas and dust. A giant star slowly breathes. Unlike our Sun, this star does not shine with the same brightness every day. It gently expands, then slowly contracts again. With every cycle, its light grows stronger, before quietly fading once more. At first, this seems like nothing more than a distant rhythm. But something beautiful begins to happen around it. The light does not travel along just one path. Some of it reaches us directly, but another part strikes the surrounding clouds of dust. It bounces gently through space, taking a much longer journey before finally arriving at Earth. Because of that delay, the surrounding clouds appear to light up one after another, as though a wave of light is slowly moving through space. It almost looks like the cloud itself is expanding, but it isn't moving at all. Only the light is. This breathtaking illusion is known as a light echo. It is similar to hearing an echo inside a quiet valley. You hear the original sound first. Then moments later, the same sound returns after reflecting from distant cliffs. Light can behave in a surprisingly similar way. Except instead of seconds, the journey may take weeks, months, or even years. To us, it creates one of the most beautiful illusions in astronomy. For scientists, it offers something even more valuable. By studying these echoes, astronomers can measure enormous distances with remarkable precision. They learn how bright these stars truly are, how far away they exist, and how vast the universe really is. A simple pulse of light becomes a cosmic measuring tape stretching across the galaxy. As the star continues its endless rhythm, the surrounding darkness responds in silence. Every flash, every reflection, every delayed beam of light carries another small piece of the universe's story. And once again, you drift quietly forward, leaving another extraordinary wonder behind. Space often feels peaceful, calm, almost motionless. But beneath that silence, invisible forces are constantly at work. Ahead of you, a spiral galaxy slowly drifts toward an enormous galaxy cluster. From a distance, nothing seems unusual. Its elegant spiral arms still shine across the darkness. Billions of stars continue their quiet journey around its center. But the galaxy is not moving through empty space. The cluster surrounding it is filled with an ocean of extremely hot gas. Although completely invisible to your eyes, it stretches across millions of light years. As the galaxy moves deeper into this hidden sea, something begins to change. The stars continue forward almost untouched. But the clouds of gas inside the galaxy face an invisible wind. Little by little, that wind starts pulling them away. Long streams of glowing gas trail behind the galaxy, like silk drifting through still water, or the glowing tail of a cosmic comet. The galaxy slowly leaves pieces of itself behind. Astronomers call this process RAM pressure stripping. It happens over millions of years, slow enough that no living creature could ever watch it unfold from beginning to end. Yet the evidence is written across the sky. Brilliant blue filaments, delicate streams of glowing gas, and long cosmic tails stretching far into the darkness. Every passing million years removes more of the galaxy's raw material. Without that gas, new stars can no longer be born. The bright spiral arms that once created countless suns gradually fall silent. The galaxy begins to grow older, calmer. Its brilliant youth slowly fades away. Eventually, it may become a completely different kind of galaxy. A quiet collection of aging stars, where the brilliant nurseries of new suns no longer exist. As you drift past, the transformation feels almost peaceful. Not because nothing is happening, but because the universe never rushes. Even its greatest changes take place in perfect silence. As you leave the distant galaxies behind, countless stars begin gathering once again. Not into planets, not into galaxies, but into something just as extraordinary: a globular cluster. From afar, it looks like a single glowing sphere. But as you slowly approach, the light begins to separate. One star becomes hundreds. Hundreds become thousands, until an entire city of ancient suns fills the darkness before you. More than 100,000 stars, all bound together by gravity, moving in perfect harmony. These are among the oldest structures in our galaxy. Many were already ancient, long before Earth existed, long before the first oceans formed. Some have spent more than 12 billion years orbiting the Milky Way, quietly surviving while galaxies collided. Stars were born, and civilizations had yet to imagine the night sky. Unlike young star clusters, very few new stars are born here. The brilliant blue giants have long disappeared. What remains are older, calmer, golden stars. Their lives move slowly, their light softer, their story nearly complete. Yet these ancient clusters still hold remarkable secrets. By measuring the stars inside them, astronomers can estimate their ages with incredible precision. They become natural clocks, helping us understand when our galaxy first began to grow. Some clusters even hide something far more mysterious. Deep within their crowded centers, gravity becomes incredibly strong. Thousands of stars circle through an impossibly small region. Some scientists believe that hidden there lies an intermediate mass black hole, a missing link between the small black holes formed by dying stars and the supermassive giants that rest at the hearts of galaxies. No one has seen it directly, only its silent influence. The gentle pull, the unusual motion of nearby stars, tiny clues scattered across the darkness. As you drift between these ancient suns, Everything feels timeless. There are no explosions, no rushing winds, only countless stars, quietly continuing a journey that began billions of years before our own. And for a brief moment, you become one more silent traveler among them. Long before space telescopes, long before digital cameras, the universe looked very different. Not because the stars were different, but because our eyes could only see so much. Centuries ago, astronomers spent long nights looking through simple telescopes. There were no photographs to preserve what they saw, no computers to record distant galaxies, only paper, ink, and patience. Every crater on the moon, every faint cloud inside a nebula, every tiny point of light had to be drawn by hand. Each observation depended on the observer. Two people could look at the same object and create two very different drawings. The universe remained beautiful, but it was difficult to measure. Then, everything began to change. Photography arrived. For the first time, light could write its own story. Instead of disappearing the moment it reached a telescope, it could be captured, stored, studied again and again. Long exposures collected light for hours. Stars too faint for human eyes slowly appeared on the photographic plates. The darkness became filled with objects no one had ever seen before. But technology kept moving forward. Film eventually gave way to something far more powerful. Electronic detectors. Every tiny particle of light, every photon arriving from across the universe, could now be recorded with extraordinary precision. Modern CCD cameras transformed astronomy forever. Images became sharper, observations became faster, and details once hidden inside the darkness suddenly emerged. Colors invisible to human eyes revealed the true structure of distant nebulae. Galaxies separated into billions of individual stars. Clouds of gas exposed the places where new suns were quietly being born. Today, astronomers no longer spend months creating a single detailed sketch. Powerful computers process enormous images in moments. Each observation contains millions of tiny pieces of information. Every pixel, another clue, another step toward understanding the universe. Yet despite all this remarkable technology, the purpose has never changed. We still do exactly what those early astronomers dreamed of doing. Looking farther, seeing more clearly, and asking the same timeless question: what waits beyond the next horizon? Your journey continues. The darkness around you seems endless, yet much of the universe still remains hidden. Not because it is too far away, but because your eyes were never meant to see it. Every object around you shines in its own way. Some glow brightly in visible light. Others remain almost completely invisible, wrapped inside cold clouds of gas and dust. They quietly wait beyond ordinary vision. To find them, astronomers had to learn to see a different kind of light. Not the colors your eyes recognize, but infrared light. Light with wavelengths just a little longer, yet capable of revealing an entirely different universe. When Hubble received its new wide-field camera 3, everything changed. Its vision became sharper. Its reach became greater. Most importantly, it could now explore regions that had remained hidden for decades. Dense clouds of cosmic dust no longer formed an impenetrable wall. Instead, they became transparent. Behind them, entire nurseries of newborn stars slowly emerged. Stars that had spent millions of years hidden inside enormous clouds finally became visible. It was as though someone had gently lifted a curtain that had covered the universe since the beginning. But infrared light offered something even more extraordinary. It allowed Hubble to look farther back in time. As the universe expands, the light from distant galaxies stretches during its long journey across space. The farther the galaxy, the more its light shifts toward the red. Eventually, visible light becomes infrared. Without infrared vision, some of the oldest galaxies would simply disappear from view. They would still exist, but we could never see them. With its new camera, Hubble began discovering galaxies whose light had traveled for more than 13 billion years. When that ancient light first started its journey, neither the Earth nor the Sun had yet come into existence. You are not simply looking across space. You are looking across time itself. Every distant galaxy becomes another page from the universe's earliest history. Every faint point of light, a message carried across billions of years. As you continue drifting forward, you begin to understand something remarkable. The deeper we look into space, the younger the universe becomes. And somewhere ahead, the very first chapters of the cosmos are still waiting to be seen. The farther you travel, the quieter the universe becomes. The stars around you grow fewer. The darkness grows deeper. At first, it seems as though there is nothing left to discover. But appearances can be deceiving. You now focus your attention on one of the smallest regions of the sky. So small that if you held a grain of sand at arm's length, it would easily cover it. To the naked eye, it looks completely empty. No stars. No galaxies. Only darkness. Yet Hubble remained fixed on that tiny patch of sky. Not for minutes. Not for hours. But for days. Patiently collecting every faint photon that reached its mirror. Slowly, the darkness began to disappear. Tiny points of light emerged. Then hundreds more. Soon, thousands of distant galaxies filled an area that had once appeared completely empty. Each one containing billions of stars. Each one separated from the next by unimaginable distances. What seemed like empty space was anything but empty. Some of these galaxies are so distant Their light began its journey more than 13 billion years ago, when those photons first left their galaxies. The universe itself was still young. The first generations of stars had only recently begun to shine. Galaxies were smaller, less organized, still learning how to become the magnificent structures we see today. The light reaching your eyes now has been traveling almost since the beginning of cosmic history. It crossed expanding space, passed through countless galaxies, and survived an endless journey across billions of years, only to arrive here. At this very moment, you are not witnessing the present. You are witnessing a memory, a message sent from an age so distant that even time itself feels different. Every faint galaxy becomes another chapter in the story of creation. Another piece of evidence revealing how the universe slowly grew from simplicity into the breathtaking cosmos surrounding you today. As you continue drifting through the silence, you begin to realize something extraordinary. The deeper we look into the universe, the closer we come to the very first dawn of existence. Far ahead, a faint glow slowly appears against the darkness. At first, it resembles an isolated cloud suspended among the stars. But as you move closer, its true nature begins to reveal itself. This is the Large Magellanic Cloud, a small companion galaxy, quietly orbiting the Milky Way for billions of years. Although much smaller than our own galaxy, it is one of the most active stellar nurseries in our cosmic neighborhood. Here, the universe is constantly creating something new. Immense clouds of hydrogen drift through space. Cold, silent, almost motionless. Then, over countless millions of years, gravity begins its patient work. The clouds slowly collapse. Their centers become hotter, denser, brighter, until one quiet moment, a new star is born. Its first light spreads through the surrounding gas, illuminating enormous clouds that had remained hidden in darkness for ages. The brilliant young stars release powerful streams of radiation. Their energy pushes against the very clouds that created them. Towering pillars of gas begin to break apart. Dark dust slowly drifts away, and new generations of stars prepare to emerge from what remains. It is an endless cycle. One star gives birth to another. One cloud disappears, only for a new one to begin forming somewhere nearby. Nothing here remains unchanged. Every glowing nebula, every brilliant cluster, every cloud of dust is part of an ongoing story that has continued for billions of years. As you drift silently through this glowing landscape, it feels less like watching the birth of stars, and more like witnessing the universe learning how to create light. Perhaps every atom within your own body once passed through a place like this, forged inside ancient stars, scattered across space, and gathered together again to become part of a new story. Your own. The universe has been creating, recycling, and beginning again, long before the Earth existed. And it continues, even now, in complete silence. Your journey has carried you across galaxies, through ancient star clusters, past invisible waves of gravity, and into the earliest chapters of the universe. With every new discovery, one truth has become impossible to ignore. The universe is far greater than we once imagined. Every answer reveals another question. Every horizon hides another beyond it. For more than 3 decades, Hubble has quietly circled the Earth, orbit after orbit, night after night, watching the universe with remarkable patience. Its mirrors have captured the birth of stars, the collisions of galaxies, the silent growth of black holes, and light that began its journey billions of years before our own world existed. Each image has expanded our understanding of the cosmos. Yet Hubble has never claimed to reveal everything. It was never meant to provide the final answer, only the next step. Science moves forward because curiosity never stands still. Every generation builds instruments capable of seeing farther than the one before. Each new telescope opens another window into the unknown. The universe rewards those who continue looking. Somewhere beyond the galaxies we have already explored, countless others remain unseen. Stars are forming at this very moment. Planets are taking shape inside clouds of dust. Black holes continue bending space and time. Light begins journeys that will not end for billions of years. The universe never pauses. Its story continues whether someone is watching or not. Perhaps one day, another telescope will look beyond even Hubble's greatest achievements. It will reveal galaxies older than any we have ever seen. Worlds unlike anything we have imagined. And new mysteries that no one today can predict. That is the beauty of exploration. Every discovery reminds us how much still remains hidden. As you quietly drift through the endless darkness, there is no feeling of reaching an ending. Only the peaceful realization that the journey can always continue. Because the universe has no final chapter. Only another page waiting to be discovered. The universe has always been larger than our imagination. Every generation believes it has reached the edge of knowledge. Then another discovery quietly changes everything. A new telescope, a deeper observation, a faint signal arriving from farther away than anyone expected. Each step reminds us how little we truly know. Some of the light surrounding you tonight has traveled across billions of years. It crossed an expanding universe without ever stopping. Only now has it finally reached your eyes. You are sharing a single moment with light that began its journey before the Earth existed. Few experiences are more extraordinary than that. As you continue drifting through the silence, you may begin to notice something. The universe never feels rushed. Stars are born in their own time. Galaxies grow over unimaginable ages. Even the greatest events unfold with remarkable patience. There is no need to hurry here. The cosmos has been waiting for billions of years. It can wait a little longer. Perhaps that is why looking into space feels so peaceful. It reminds us that not everything needs to happen today. Not every answer must arrive immediately. Some mysteries are beautiful simply because they remain mysteries. Tonight, you have traveled across worlds. You have followed ancient light through the darkness. You have witnessed galaxies, stars, and silent clouds of cosmic dust. And yet, this is only a tiny fraction of what the universe contains. Beyond every horizon, another horizon still waits. Beyond every discovery, another mystery quietly calls. For now, your journey comes to a gentle pause. The stars will remain exactly where they are. The galaxies will continue their silent dance. And the universe will patiently wait for the day you decide to return once again. Until then, rest peacefully beneath the same sky that has inspired explorers for countless generations. Good night. As the stars slowly fade into the distance, you realize that this journey was never only about space. It was also about perspective. From here, the worries of everyday life become impossibly small. The borders we draw on maps disappear. The noise of the world falls silent. Only one small blue planet remains, floating peacefully around an ordinary star, among hundreds of billions of others. Everything you have ever known, every mountain, every ocean, every story in human history, exists on that tiny world. Seen from this distance, it feels both fragile and incredibly precious. Perhaps that is one of the greatest gifts the universe offers. Not only wonder, but gratitude. The night sky reminds us that we are part of something far greater than ourselves. The same atoms that form distant stars now form every breath you take, every heartbeat, every thought. In a very real way, the universe has always been with you, and it always will be. The stars above will continue shining. New worlds will continue forming. Ancient galaxies will continue their endless journey through the darkness, long after tonight has passed. For now, there is nothing left to do, nothing left to chase. Simply allow yourself to rest. Let the quiet of the cosmos surround you. Let the silence become comforting. And let your thoughts drift as gently as the galaxies themselves. Sleep peacefully. The universe will still be here when you open your eyes again. The universe does not ask for attention. It simply exists. Quietly. Patiently. Every star continues to shine without knowing who is watching. Every galaxy follows its path without ever changing its course. There is something comforting about that. The cosmos asks nothing from you. It does not expect answers. It does not measure success. It simply invites you to observe, to breathe, to slow down. Perhaps that is why so many people find peace beneath the night sky. For a little while, life becomes wonderfully simple. There is only silence, only distant starlight, only the endless rhythm of the universe. Some of the stars above will disappear long before their light stops reaching Earth. Others have already faded away. Yet their final rays are still traveling through space. Even in darkness, light continues its journey. Perhaps there is something beautiful in that thought. Not everything ends the moment it can no longer be seen. Some things continue far beyond our awareness. The universe reminds us of this every single night. As your journey slowly comes to rest, allow your thoughts to become lighter. Allow the silence to grow deeper. There is nowhere else you need to be. Nothing else you need to do. The stars will keep watch. The galaxies will continue their silent dance. And somewhere in the endless darkness, ancient light will continue traveling toward tomorrow. Good night. Sleep well. The universe is still waiting. The night grows quieter with every passing moment. The stars remain exactly where they have always been. Patient. Silent. Unchanging. You have crossed unimaginable distances. You have looked into places where light has traveled for billions of years. You have witnessed worlds that existed long before our own. Yet the greatest feeling you carry home is not wonder. It is peace. The universe has a remarkable way of slowing the mind. Out here, time loses its urgency. There are no crowded streets, no endless notifications, no race against the clock. Only quiet, only space, only the gentle rhythm of a cosmos that has never needed to hurry. Perhaps that is why the night sky has fascinated humanity for thousands of years. Not because it gives us every answer, but because it reminds us that it is perfectly acceptable not to have them all. Some mysteries deserve patience. Some questions deserve silence. And some journeys are meaningful simply because we choose to take them. As you begin to rest, imagine the stars continuing their endless voyage above you. The moon quietly following its familiar path. The planets circling the sun exactly as they have for billions of years. Nothing has changed. And yet, perhaps you have. Maybe tomorrow the sky will feel a little larger. Maybe the stars will seem a little closer. Maybe you will look upward with a little more curiosity than before. For tonight, that is enough. Close your eyes. Let the silence carry you. And let the universe keep watch until morning. The search for intelligent life is one of humanity's greatest journeys. Among everything we have discovered in the known universe, the human brain remains one of the most extraordinary creations. Around 86 billion neurons work together, giving us the ability to imagine, create, and reshape the future. But is this truly the highest form of intelligence the universe has ever produced? Astronomers estimate that our universe may contain trillions of potentially habitable planets. Each one represents another possibility, another chance for life to emerge, another place where intelligence may have taken a very different path. the search for extraterrestrial civilizations is far more than a scientific mission. It is driven by one of the oldest questions humanity has ever asked. Are we alone? Finding another intelligent civilization would do far more than answer that question. It would completely transform the way we see ourselves. For the first time in history, we would know that Earth is not the only home of conscious life. Unlike simple microbial life, advanced civilizations may leave traces that can be detected across thousands of light years. Their technology, their signals, even the way they shape their worlds could reveal their existence. But what do they know that we do not? And if they are out there, how could we ever reach them? We are not the first generation to wonder. More than 2 centuries ago, people even imagined lighting enormous fires across the Sahara Desert, hoping another civilization might notice our presence. Simply knowing that someone else exists among the stars would forever change our place in the universe. Perhaps we would finally feel connected to a much larger cosmic family. And if we could understand even a small part of their knowledge, their science, or their technology, it might help humanity survive for far longer than we ever imagined. But there is also another possibility. What if, after searching for centuries, we never find another intelligent civilization? What if the silence of the universe is real? We may never know with absolute certainty. The universe is simply too vast. There will always be distant galaxies so far away that we will never have the ability to explore them. Yet if we continue searching and find nothing, it could mean that intelligent life is unimaginably rare, perhaps even unique. If that is true, then the responsibility placed upon humanity becomes far greater. We would not simply be another civilization among many. We could be the keepers of one of the rarest sparks in the entire cosmos. Just as ancient civilizations left monuments behind for future generations, we, too, could leave something that survives long after we are gone. Great libraries, enduring archives, messages carved into machines built to outlive our planet. Cosmic time capsules carrying the story of our species across millions of years. Perhaps one day, another civilization will discover them. And perhaps they will leave their own legacy behind as well. Each new civilization adding another chapter to an endless chain of knowledge stretching across the galaxy. It is even possible that humanity is destined to become one of the very first links in that chain. The founders of a galactic library that future civilizations may continue to build. Even if we never meet them ourselves, we are still newcomers to the cosmic stage, driven by curiosity, guided by hope, always searching for something greater than ourselves. That search may take thousands of years, perhaps even millions. But as long as the unknown remains, humanity will continue looking toward the stars. Centuries ago, people believed that if another civilization existed, all they had to do was announce their presence. Some imagined lighting enormous circles of fire across the Sahara Desert. Others proposed placing gigantic mirrors on Earth's surface to reflect sunlight into space. The idea was simple. If someone was watching, perhaps they would notice. Today we understand that space is far too vast for light reflected from a mirror, or flames burning on a distant world, to travel across meaningful cosmic distances. Even if a nuclear war erupted on a nearby planet, detecting it with our current technology would be extraordinarily difficult. To communicate across the stars, we need something far more powerful: radio waves. Unlike visible light, radio waves travel through the thin gas and dust between stars with relatively little interference. They can carry information across enormous distances, making them one of the best tools for interstellar communication. For decades, scientists have listened carefully for unusual radio signals that might have been intentionally transmitted, or simply leaked into space by another civilization's technology. Humanity has been doing exactly the same thing. Since the invention of powerful radio transmitters, our own broadcasts have been expanding outward at the speed of light. Today, that invisible bubble has already reached dozens of nearby star systems. Some of those stars may host planets capable of supporting life. If intelligent beings live there, they could, in theory, detect the faint signs of our civilization, even without hearing our radio transmissions. They might notice something else: Earth's atmosphere. The large amount of oxygen surrounding our planet is difficult to explain through geology alone. It is a powerful fingerprint of life. A distant civilization studying our world might already know that something alive exists here. Yet despite decades of searching, our exploration has only just begun. Compared with the unimaginable size of the observable universe, the portion we have examined is astonishingly small. If the entire universe were as vast as Earth's oceans, everything humanity has searched so far would amount to less than a single swimming pool. And there is another possibility. Perhaps we are searching for the wrong kind of signal altogether. There may be many ways for civilizations to communicate across the stars. Radio waves are only one possibility. To a civilization thousands or even millions of years more advanced than us, our technology might seem incredibly primitive. That is why scientists are beginning to widen the search. One possibility is laser communication. Powerful laser pulses can outshine an entire star for a brief moment. They are capable of carrying enormous amounts of information, far more than radio signals. If aimed precisely, a laser beam could travel across interstellar space like a lighthouse cutting through the darkness. As the beam spreads over great distances, it could become wide enough to illuminate entire planets. Perhaps advanced civilizations are already sweeping the galaxy with these brilliant flashes, waiting for someone to notice. Several observatories are now searching the sky for exactly these kinds of signals. But even lasers may not represent the final stage of communication. There is something even stranger. Neutrinos. Every second, trillions of these tiny particles pass through your body without leaving a trace. They travel through planets, stars, even entire worlds, almost as if nothing were there at all. detecting them is incredibly difficult. Huge underground observatories can spend an entire day capturing only a handful of them. Yet scientists have already demonstrated that information can be transmitted using neutrinos. If an advanced civilization mastered this technology, their messages could pass effortlessly through planets and stars, traveling silently across the galaxy. It is even possible that such messages are passing through Earth right now, flowing through every living thing, completely unnoticed. Or perhaps their methods are stranger still. Instead of sending signals through space, they may use space-time itself. In theory, powerful gravitational waves could carry information across the universe. Creating such waves would require unimaginable amounts of energy. But for a civilization far beyond our own, even the impossible may become ordinary. Perhaps the answer is far simpler. Imagine placing enormous structures around a star. Not to hide it, but to control its light. By carefully blocking portions of a star's brightness, an advanced civilization could create deliberate patterns. A cosmic Morse code. The message would travel as far as the star's own light, visible across incredible distances. It would take years, perhaps centuries, to transmit even a simple conversation. But once built, such a system could continue sending its message with almost no additional effort. There is an even more extraordinary idea. What if intelligent life left messages inside life itself? A few scientists have suggested that if an advanced civilization once engineered the origins of life, they may have hidden information within the genetic code. Not instructions for survival, but a signature. A message waiting to be discovered by a civilization advanced enough to read it. At the moment, there is no evidence that such a message exists. But the idea reminds us of something important. The universe may be filled with possibilities we have not yet imagined. There is also another explanation for the silence. Perhaps we are simply living at the wrong time. Computer simulations suggest that intelligent civilizations may not appear evenly throughout the galaxy. Some studies indicate that the peak era of advanced life could have occurred billions of years before humanity ever appeared. If that is true, then we may have arrived long after the galaxy's greatest age of civilization had already passed. Imagine walking into a city, only to find its streets empty, its lights extinguished, its people gone. The buildings remain, but the voices have faded into history. Perhaps one day, what we discover will not be living civilizations, but their ruins. Ancient structures drifting silently through space. Silent witnesses to a forgotten chapter of the universe. Whether we ever find them depends on one simple question. How long can a civilization survive? If most technological societies destroy themselves after only a few centuries, then the chance of two civilizations existing at the same moment becomes incredibly small. They would appear, disappear, and vanish before anyone else had the opportunity to notice. But if even a few civilizations endure for thousands or millions of years, the universe suddenly becomes a much less lonely place. Even if another civilization chooses to remain completely silent, that does not mean it would be impossible to find. Perhaps we have been looking in the wrong place all along. Instead of searching for messages, maybe we should search for technology. Not the ambassadors, but the engineers. Every civilization, no matter how different from our own, must solve one universal challenge: energy. The more advanced a civilization becomes, the more energy it will need. One way scientists think about this is through the Kardashev Scale. It measures civilizations not by their intelligence, but by the amount of energy they can control. A Type 1 civilization can harness nearly all of the energy available on its home planet. It can manage its climate, control its resources, and use the full power of its world. Humanity has not reached this stage yet. We are still only beginning that journey. A Type 2 civilization goes much further. Instead of relying on a single planet, it captures the energy of its entire star. And a Type 3 civilization commands the power of an entire galaxy. To us, such beings would seem almost impossible to comprehend. As different from humanity as humanity is from the simplest forms of life. But before we dream of discovering civilizations that powerful, perhaps we should first learn how to recognize those only slightly more advanced than ourselves. One possible clue may already exist around distant planets. When a planet passes in front of its star, the star's light briefly becomes dimmer. Astronomers use this tiny change in brightness to discover new worlds. But what if the pattern looked unusual? What if the fading happened slowly, or followed a shape that nature rarely creates? One explanation could be a vast network of artificial satellites surrounding the planet. Some scientists refer to this hypothetical structure as a Clark belt. Finding such a signature would not prove intelligent life, but it would certainly give us a reason to look much closer. Technology, just like life itself, may leave fingerprints across the universe. We simply have to learn how to recognize them. Technology may leave traces, just as living organisms leave biological signatures. One possibility is silicon. Much like chlorophyll gives plants a recognizable spectral fingerprint, large-scale silicon solar panels could create their own unique pattern of reflected light. From many light-years away, astronomers might detect that unusual signature and realize it was not created by nature. Another possible clue is pollution. On Earth, certain industrial chemicals do not occur naturally. Compounds such as chlorofluorocarbons can remain in an atmosphere long after they are released. If similar chemicals were detected on a distant world, they could reveal the presence of an industrial civilization. Even if that civilization had already disappeared, its atmosphere might continue carrying evidence of its existence for thousands of years. A discovery like that would be more than proof that intelligent life once existed. It could also serve as a warning, a reminder that technological civilizations may not last forever. There is another universal consequence of technology: waste heat. Every machine, every city, every source of energy eventually releases heat. The more advanced a civilization becomes, the more excess heat it must produce. That waste heat could become one of the easiest signatures to detect across interstellar distances. Instead of searching for messages, astronomers may simply look for worlds radiating more heat than nature alone can explain. If a civilization survives long enough, it may eventually gain complete control over its home planet. A true Type 1 civilization. Such a society could regulate its climate, manage its ecosystems, control its natural resources, and reshape its environment on a planetary scale. Yet no matter how advanced a civilization becomes, certain dangers remain universal. Gamma-ray bursts, nearby supernovae, asteroid impacts. These are threats that every civilization in the galaxy must face. Some may choose to spread beyond their home world, building settlements between the stars, reducing the risk that a single catastrophe could erase their entire civilization. If that is true, our search cannot focus only on planets. We must also search the vast darkness between them. Civilizations that remain on their home planets for long periods may eventually need a new form of protection: a planetary shield. In theory, a massive defensive structure surrounding a world could protect it from dangerous asteroids, powerful solar storms, or other cosmic threats. As such a structure passed in front of its star, it could produce a highly unusual dimming pattern. It might also radiate detectable amounts of heat. Large-scale engineering projects like these would require unimaginable quantities of raw materials. Mining an entire planet would be inefficient. Asteroids offer a far better solution. They are rich in valuable resources, and their weak gravity makes them much easier to move and process. One day, astronomers may discover asteroid belts displaying strange thermal signatures, or chemical patterns that natural processes cannot explain. Such anomalies could be the fingerprints of extraterrestrial mining operations. But eventually, even the resources of countless asteroids may no longer be enough. Our own civilization is still very young. If other intelligent species exist, many of them are likely to be far older and far more advanced than we are. That is why some scientists argue that humanity should think carefully before announcing its presence to the galaxy. After all, we have no idea who might be listening. Yet no matter how many resources an advanced civilization gathers, its greatest need will always be energy. Stars produce billions of times more energy than the planets that orbit them. Capturing even a fraction of that power would transform an entire civilization. To achieve this, scientists have imagined one of the most extraordinary engineering projects ever conceived: a Dyson sphere. Rather than a single solid shell, which would be unstable. A more realistic design would consist of countless satellites, habitats, and energy collectors orbiting the star together. This vast swarm, often called a Dyson swarm, could harvest an enormous portion of a star's energy. Such a structure would also generate large amounts of infrared waste heat. It could periodically block part of the star's light and leave unmistakable signatures that astronomers might detect from across the galaxy. Any civilization capable of harnessing the full energy of its star would reach the next stage on the Kardashev Scale, a Type 2 civilization. At this level, its technological capabilities would seem almost limitless. One concept that has fascinated scientists is called star lifting. Instead of simply collecting a star's energy, a civilization could slowly extract material directly from the star itself. Those resources could provide enough matter to build countless worlds, or support civilizations on an unimaginable scale. Star lifting could even extend the life of a star. By carefully removing material, its evolution might be slowed, allowing it to shine for far longer than it naturally would. Our own sun will gradually become too hot for life on Earth, long before it dies. Its increasing brightness will eventually make our planet uninhabitable. If humanity ever learned how to control a star in this way, it could prolong the lifetime of our solar system by billions of years. But perhaps even the energy of an entire star would not satisfy a civilization that continued to grow. To spread across a galaxy, travel over enormous distances would become essential. Journeys approaching the speed of light might become routine. And if such spacecraft existed, we might one day detect them. A vessel slowing down from relativistic speeds could leave behind long trails of ionized gas. Those trails might emit faint infrared radiation, visible to sensitive telescopes. Eventually, a civilization capable of controlling the energy of an entire galaxy would reach the highest level of the Kardashev Scale, a Type 3 civilization. Its achievements would be almost impossible for us to imagine. Billions of Dyson structures, the ability to reshape entire stellar systems, perhaps even the power to create new stars. To beings like that, human civilization might appear no more significant than microscopic life appears to us. One possible way to search for such civilizations is to look for what should be there, but isn't. Entire regions of a galaxy missing their expected starlight, as though the energy of countless stars had been captured. For many years, some astronomers wondered whether unusually dark regions between galaxies might be evidence of such immense engineering projects. Later observations, however, showed that these vast cosmic voids are natural structures formed during the evolution of the universe. Recent surveys of nearby galaxies have found no convincing evidence of galaxy-spanning civilizations. At least, not yet. If civilizations of that scale truly exist, perhaps they have chosen not to reveal themselves. Or perhaps their technology is simply beyond anything we know how to detect. Still, if we are fortunate, they may leave behind something impossible to ignore. something that clearly distinguishes intelligence from nature. In theory, a civilization capable of engineering entire planetary systems could create structures far more complex than anything formed through natural processes. The search for intelligent life has always been about more than science. For thousands of years, humanity has searched for answers to the same profound question. Whether through philosophy, religion, or astronomy, we have always looked beyond ourselves, hoping to find something greater. The search for extraterrestrial intelligence is simply the modern continuation of that timeless journey. Both pursuits are driven by the same desire: to understand our place in the universe, to know whether consciousness exists elsewhere among the stars, and to discover if we are truly alone. One day, perhaps we will detect a signal. Perhaps we will uncover an ancient artifact drifting silently through interstellar space. Or perhaps we will find unmistakable evidence written across the light of a distant star. Whatever the first discovery may be, it will forever change humanity. For the first time, we will know that life found a way. Not just once, but more than once.